Welcome. We'll be discussing Chapter 1, the intro chapter to Introductory Statistics EPSY 5380. So, statistics. What does that term refer to? Often facts and figures. So, for example, average snowfall, average midterm score, which students are always concerned with, batting average. Lots of different sports have a variety of statistics that are reported. So we're all pretty familiar with different statistics that float around us in the news and just in common parlance with other individuals. So what are some other statistics? I'm sure you can all think of some that might be applicable to your situation. But what is statistics really? Well, the official definition is a set of mathematical procedures of organizing, summarizing, and interpreting information. Basically trying to make sense out of the world, bring order out of chaos, to see patterns and trends so that you can effectively manage and intervene in your situation, whatever that may be. So Graveder and Wall now discuss two purposes of statistics. One, to organize and summarize information so that it may be communicated. So a descriptive purpose so that you can communicate to others what is going on in a certain phenomenon or situation. To answer research questions based upon data collected and make appropriate conclusions. So to infer from the data. So you can make an inference about the data, which is inferential statistics. So you have a descriptive purpose and an inferential purpose in statistics, generally speaking. So population versus sample. These are two distinct concepts. A population is a set of all individuals of interest in a particular study. So the entire sampling frame of individuals of a particular class or distinction for a particular study. So if you were wanting to look at college student drinking, you would need to collect a sample of all college students, which would be a population, but that's very difficult to get. So we rely on samples. A sample is a set of individuals selected from a population, usually intended to represent the population in a research study. So our sample can never fully represent the population. Now, based on the law of large numbers, it can approximate the population pretty well, but can never fully represent the population. So what are variables? Variable is a characteristic or condition that changes or has different values for different individuals. So the variable of gender has two values, male and female, generally speaking. So what are some other variables? Okay, so going back to the college student drinking example, college students can have, one of four classifications for undergrads. So freshman, sophomore, junior, senior. So there's four values for the variable of college student classification. And what is the opposite of a variable? An opposite of a variable is a constant. So a constant would be something that doesn't have any other values. It's just one value. So if you're looking at college student drinking, the variable of college student status, like whether or not they're a college student, would be all ones, or it would be all yes, they are college students, and that's a constant. And you really can't do much analyses with a constant because there is no variability, so there's really nothing to look at. So data are plural. They're measurements and observations. So it's data are, not data is. It's easy to say data is, so believe me, but it's data are, so it's a plural term. Datum is a singular measurement or observation, so be careful there. And aka a score or raw score. So a single score for an individual, like their, IQ test score, that's a datum. Now if you're looking at for a sample, those are data. Parameters versus statistics. Parameters are values that describe a population. So the entire possible sampling frame, the entire breadth of a population. Statistics are values that describe a sample. So notice that this class is called statistical methods and not parametric methods. And that's because we deal with samples and not populations, because we can't achieve populations even if we wanted to, just logistically and time and money. So it's hard to get a whole population. It's descriptive statistics summarize, organize, and simplify data. So that goes back to the two purposes of statistics according to Graviner and Wallnau. So we have descriptive statistics, and this is what you're all familiar with. You know, it's very basic. You know, you hear it on the news or commercials, like 1 in 4 dentists prefer Crest toothpaste. You know, those are very common descriptive statistics. And then inferential statistics. They allow you to study samples and then make generalizations about the populations from which they're selected. So you'll be able to say that SAT scores or GRE scores predict future student performance in the respective area of study. So that's inferential statistics. Okay, sampling error. Sampling error is something that we deal with because there's always some amount of discrepancy or error that exists between the sample statistic and population parameters. You can't have your sample fully represent the population. It always falls a little bit short. We know that our sample will only represent a population to a certain degree. Now we want to make that degree as high as possible, but we always know that there'll be some amount of sampling error. And some samples are obviously better than others in representing populations. So did you get a sample that was truly representative of the population? So, and you can make sure that you can achieve that. You can make sure that you understand the characteristics of your population in terms of like gender, ethnicity, age, and then of course get a sample that is representative by seeking out a diverse group that is representative of the population. So correlational versus experimental. A correlational design has 2 or more variables that are observed. Notice the word observed, to determine whether there is a relationship. An experimental design is where one variable is manipulated while another is observed or measured. And the goal in the experimental design is to establish a cause and effect relationship. That is not the goal in a correlational design. So, more in experimental designs, they have 2 key characteristics. Manipulation. A researcher manipulates one variable called the independent variable. So the researcher manipulates it. So it'd be like a condition of a variable. So let's say reading programs. So you have one is a whole language learning reading program, and one is like hooked on phonics. So 2 different reading programs that you would manipulate. And the control. Researcher controls the influence of variables that are unwanted sources of variation. So like previous academic achievement and seeing how students do or perform in different reading programs. These are control variables. So you want to control out for previous achievement and look at the actual effect or isolate the effect of the different reading programs. So unwanted sources of variation can be participant variables, so like previous achievement as I mentioned, and environmental variables. So that's more like you control the conditions in which testing occurs. Like you don't have people walking by shouting in one condition, and another condition you have everything quiet. So you look at environmental variables in experimental designs as well. So independent variables are manipulated and have 2 or more values. So what are some variables that you can manipulate? Can you manipulate gender? No, you can't. Well, I guess you can, kinda. That takes a lot of work. But generally, as a researcher, you can't. Yeah, I guess an individual person could manipulate it. But anyway, so because there's two values, and that researchers generally can't manipulate that. And the dependent variable is observed or measured to assess the effect of the IV or treatment variable. So the dependent variable is dependent, that's the way of thinking of it, upon the independent variable. Quasi-independent variables are IVs that are observed but not manipulated. So that would be gender. You observe it, but as a researcher, you don't manipulate it. Constructs. Constructs are internal attributes that cannot be observed but are useful for describing and explaining behavior. These would be like coping skill, self-efficacy, you name it, because there is not one clearly observed way of measuring it or defining it. So it's not like gender, you're male, you're female, or student classification, freshman, sophomore, junior, senior. And those are very well described or distinct by number of hours that a student has achieved or earned in their college experience. But constructs are a little bit more fuzzy. They refer to internal attributes. They're not directly observable. You can ask a bunch of questions to get at them, to measure those constructs, but they're not directly observable. So they're hypothetical or theoretical. And as I mentioned, some constructs are coping skill, self-efficacy, approaches to learning. Those are all different constructs, and there's a gazillion more you could think of. So as these constructs are difficult to measure, we must operationalize them. So what does that refer to? We develop a measurement procedure or procedures to measure an external behavior to measure a construct. So how do we measure the construct of self-regulated learning? So if we want to know if a learner is self-regulated, how do we do that? Well, we can ask them questions of, how's your time management? Do you organize your work? Do you invoke task strategies? I'm trying to think of another one. Do you engage in help-seeking behavior? So these are all questions that we can get at to find out whether a learner is self-regulated in their process of online or wherever. Okay, so another way to think about is IQ. Or intelligence we measure by IQ tests. So that's a way of operationalizing. We measure depression by BDI, Beck's Depression Inventory. That's one. There's a couple more. And same thing for IQ tests. There's different measures of that. And then going on to discrete versus continuous. In operationalizing the same track, you have to decide on your level of measurement. Sometimes the nature of the construct decides for you. So like in parenting styles, there's 4 different types: the authoritarian, authoritative, permissive. Oh my gosh, I forgot the last one. Anyway, there's a 4th. And so that's very discrete. There's 4 levels there. Discrete variables consist of separate indivisible categories, so whole numbers. So you're either a 1, 2, 3, or 4, or like in gender, you're either a 1 or 2, 1 being male, 2 being female, or vice versa. Continuous variables have infinite values, so you can range from 0 to 100, and you can have values like 0.5 and 0.6, depending on the unit of measurement. So what are real limits? Real limits. Continuous variables have real limits, though, because they are the span that depends on the unit of measurement. They're not discrete. So every score of a continuous variable has an upper and real limit that is exactly halfway, please note halfway, between your score and the next or adjacent higher or lower score. So an example, take the score 150 pounds when measuring to the nearest pound. So pound is your unit of measurement. So the lower real limit, or the LRL, is 149.5, while the upper real limit is 150.5. I think that got cut off. But so it's the next unit of measurement. So what are the scales of measurement? You should be somewhat familiar with that too. So beyond discrete and continuous, there are levels or scales of measurement. There's nominal, which is purely categorical, no numeric value. Ordered or ordinal, which is ordered variables and have rank or magnitude. Interval, which have magnitude but equal intervals or spacing between values. And ratio, have magnitude, equal interval, and absolute zero. So I think I have examples. So nominal gender variable would be gender, because gender is categorical and the values don't really mean anything in terms of one being better or having greater magnitude or another. So if you classify males as one and two as female, there's no implied, well, females are better because there are two, so. Ordinal, Olympic medal. So you have a gold medal, which is first, a silver, which is second, and then third, which is bronze. So you have the different rankings there, or ordered nature of it. Now, Olympic medals are an interval because there's not equal spacing. And what I mean by that is you could get the gold medal by beating someone in a race by being 1 second faster. And then the bronze person, you could have been minutes faster than. You could have barely beat the second person, and then the second and first and second person could have beat the third person by a mile. So there's ranking, but there's not equal spacing necessarily. Now, grades have an interval scale. So there should be equal spacing in the grades in terms of continuous grades, not letter grades, but in continuous grades. So like if you grade on a 0 to 100 scale, there's equal spacing from 0 to 1 to 1 to 2 to 2 to 3. So, but not letter grades. Letter grades are actually ordinal because you can barely have an A, or you can or you could be really comfortable in your C, so you can make the argument that letter grades aren't ordinal. So, talking about continuous grades. Height and weight. Height and weight are a ratio value because they actually have a true zero or an absolute zero. The zero that means something. Trying to think of another one. Like if you measure temperature like on a Kelvin scale, that also has an absolute zero. Okay. Important notation, you have a sigma. It's the capitalized Greek letter sigma, so you'll see them interchanged. Generally refers to the capitalized one, generally refers to summation, while the lowercase one, the second one, generally refers to standard deviation for a population. We'll get into that later. Big N refers to population size, while small n refers to sample size. Order of operations, this should be review for you. Parentheses, exponents, multiplication, division, addition, and subtraction. So if you're not familiar with this, you might want to engage in some self-study and brush up on your PEMDAS of your order of your operations when doing a math problem. What should you do first? Parentheses, exponents, multiplication, division, addition, and subtraction. So you might want to brush up on that. Okay, that's the end of the presentation, and that's the intro to EPSY 5380, the first chapter. Thanks.